Today we're going to learn how to do integer subtraction. By the end of this lesson, you should be able to subtract positive and negative integers. We're going to be using integer chips for this lesson. We'll be working with subtracting integers again in the next lesson with number lines. Please remember that the red chips here indicate positive integers and the yellow chips indicate negative integers. I want to remind you as well that one positive and one negative integer chip is a zero pair because they cancel each other out. This is going to be important when we're learning how to work with integer chips in terms of subtracting positive and negative numbers. Consider the blue square your balance. Right now we have positive 6 on our balance, and we want to take away positive 2. Well, if you look at the chips that are on your balance, you can see that there are actually 6 positive chips, and there's 2 there that I can take off the balance. And when I do that, I can see that positive 6 minus positive 2 equals positive 4. And when we think of subtraction, these are the things that we're used to doing. Positive number subtract a positive number. Usually the first positive number is larger than the second positive number, but it doesn't have to be like that. What if instead of positive 6 minus positive 2, I had positive 6 minus positive 8? When you look at the blue square, there aren't 8 positive chips to be taken off, which means we need more positive chips, but I can't change the balance. The balance on this square has to equal 6. The way I can do that is I'm going to need 2 more positive chips in order to be able to take them away. So I can add those 2 positive chips and not change the balance as long as I add them with their negative pair. So 1 positive chip, 1 negative chip, this still equals 6. But it doesn't give me 8 positive chips to take away. Another positive chip, another negative chip. Again, I have now 8 positive chips that I can take away, but my balance on the blue square is still only 6 because of the zero pair. Now that I have those positive 8, I can take those away, and I'm left with negative 2. Positive 6 minus positive 8 equals negative 2. I want you to pause and record what we've done so far into your math journals. Using drawings of integer chips to model each of these expressions, I want you to show how you can solve them and what the answer would be. Pause the video to do that, and then come back and check your answer with me. With the first question, positive 3 minus positive 7, we start with positive 3 on our balance. We need to take away positive 7, which means I'm going to need 4 more positive chips. If I look at what I've got right now, I have 7 positive chips, but it also means that what I'm starting with is 7, and I'm not actually starting with 7, I'm starting with 3, positive 3. So in order to make sure that this balance stays at positive 3, which is what I need to be starting with, I have to make sure that those 4 positive chips that I've added have negative chips attached to them so that they make a zero pair. Because right now, with this picture that I have here, I have positive 3 on my square. From that, I can take away all of these positive chips. 1, 2, 3, 4, 5, 6, 7. And what I have left over is negative 4. So positive 3 minus positive 7 equals negative 4. In the next question, I start with 3 negative chips. I want to take away 6 negative chips. I don't have them. In order to get 6 negative chips to take away, I need to add 3. In order to keep my beginning balance the same, I need to add 3 positive chips, because now each of these positive and negative, single positive and negative chips is a 0 pair. They cancel each other out. So I'm starting still with -3, even though I've got these extra chips. What I want to do then is take away 6 negative chips, and that leaves me with 3 positive chips. So -3 minus -6 equals +3. Next question, I start with 3 positive chips. I want to take away 5 negative chips. I don't have any negative chips to take away, so I need 5 negative chips. In order to keep my beginning balance the same, I make sure that all of those negative chips have positive chips to turn them into net zeros. I take away the 5 negative chips, and I end up with 8 positive chips that are left over. So +3 minus -5 equals +8. -5, start off with those 5 negative chips. I want to take away +3. I want to take away +3, which means I need to add 3 positive chips to my square. Can't just add those because it changes the balance unless I add my negative chips as well. I take away my +3, and I have -8 left over. Now we're going to do a similar problem, except as a word problem rather than just starting from the numbers. So in this example, on a typical April day in Whitehorse, Yukon Territory, the temperature is -5 degrees Celsius in the morning and +6 degrees Celsius in the afternoon. Determine and explain the difference between these temperatures. So what we're looking for is basically the space between -5 and +6. Pause the video now and try to solve this on your own, and then come back and I'll solve it with you. There's actually 2 ways that you could solve this problem. One is to start with the -5 and subtract +6. The other way is to start with +6 and subtract -5. And I'm going to show you why this is true. With -5 minus +6, we start off with 5 negatives, and then we want to subtract +6, so we need to have 6 positives on our board, but in order to keep our starting value of -5, those 6 positives also have to have 6 negatives attached so that we have a net 0 between +6 and -6. We take away our +6 and we are left with -11. So -5 minus +6 equals -11. In the second question, we start with our positives. So we have 6 positives. And we want to take away 5 negatives, which we don't have. So we need to put those on the board with the positives that will help them cancel each other out, because our starting value still has to be +6. Then we're going to take away our -5. And we have +6 minus -5 equals +11. Now if you look at these two numbers, they are opposite integers. So how can both of them be correct? And to figure that out, you need to look back at the question. It says, determine and explain the difference between these temperatures. So with this one, what I am saying is that -5 degrees Celsius is 11 degrees lower, because of course the negative sign indicates lower number, than +6 degrees Celsius. If I look at this question, I am saying that +6 degrees Celsius is 11 degrees, same numeral, but it is higher. Positive number means a higher number, or at least when it's compared to -11 it does. So +6 degrees Celsius is 11 degrees higher than -5 degrees Celsius. And if you compare these two statements, you can actually get one from the other. If -5 is 11 degrees lower than +6, then obviously +6 has to be 11 degrees higher than -5. If +6 is 11 degrees higher than -5, then it's also true that -5 is 11 degrees lower than +6. And although we're dealing with integer chips and not number lines, if you look at this on a number line, and particularly on a vertical number line, which is how generally we measure temperature, 2, 3, 4, 5, 6. There's +6 degrees Celsius. This is 0. 1, 2, 3, 4, 5. There is -5 degrees Celsius. And the difference between them is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 degrees. If you start at -5 and look up, then +6 is 11 degrees higher than -5. If you start at +6 and look down, then -5 is 11 degrees lower than +6. But the numeral, this part here, doesn't change. To review the key ideas for this lesson, you can use integer chips to represent integer subtraction. There's two ways of doing that. One, if you have enough integer chips of the right color, you simply take away the number that you no longer need or that you're supposed to be subtracting. If there aren't enough integer chips of the correct color, whether they're positive integer chips or negative integer chips, or if there are not enough integer chips of the right color, you can add 0 pairs until you do have enough integer chips to remove. In addition, there are actually two ways of showing the difference between two numbers. It's not that there are two separate correct answers to math sentences, as shown here. Each of these math sentences only has one correct answer. But when you're looking at the differences between two numbers, and you're actually specifically asked for the difference between two numbers, you can either do it two different ways. You can do, in this case, the differences between +1 and -2. You can calculate +1 minus -2, which means the difference would be +3, or -2 minus +1, in which case the difference would be -3. Notice that this makes an opposite integers, +3 versus -3. Copy this into your math journal, please, and do your communicate the ideas questions.